Hi everyone. So today we are going to focus on multiplying and dividing fractions. So first we're going to go over multiplying fractions, which is really a very simple concept. There are two very similar ways to go about doing this, but I'm going to introduce both to you so that you could choose what you think is best for you. So in both methods, you are multiplying straight across, your numerator multiplied by the numerator, and your denominator multiplied by the denominator. So in method one, you just start off with that right away, and then you check at the end to see if you can simplify or reduce your answer. In method two, you actually begin to simplify your answer first using a method we call cross-canceling. So we will go over how to cross-cancel. And then after you've simplified your fractions using cross-canceling, you'll still then go ahead with those simplified fractions, multiply your two numerators together, multiply your denominators together, and then double check to make sure your answer is still in simplest form at the end. So let's do an example. I'm going to do an example of each method for you, and then you can kind of choose what works best for you, what you feel most comfortable with. So I'm going to start off with method one, multiplying straight across. So here we have 1 divided by 2 multiplied by 5 divided by 2. Please note that I'm saying the fractions as a division problem. When you see fractions like 1/2 or 5/2, they are simply just division. So just keep that in the back of your mind for future. Okay, so again, 1 divided by 2 times 5 divided by 2. So we're going to multiply our numerators together. So our numerators are our top numbers, 1 and 5. So 1 times by 5 is 5. And then we multiply our denominators, which are 2 times 2, which gives me 4. Now we would check to see if we can simplify 5 divided by 4 at all. And the answer in this case is no, and we are going to leave it as is. Okay. Next, I'm going to show you how to cross-cancel. I'm going to show you that cross-canceling method. So we have 10 divided by 4 multiplied by 5 divided by 2. So when we look at these examples, we are actually going to look at our opposite sides, which is why it's called cross-canceling. So we have our numerator in our first fraction, which is 10. And then we are going to look at the denominator in the second fraction. So we have 10 and 2. And we are going to evaluate and see if we can simplify them any further. So what number goes into both 10 and 2? The answer is 2. So 2 goes into 10 5 times, and 2 goes into itself 1 time. Then we want to check and see if we have, if we can simplify the other direction. So now we're going to look at 5 and 4. So just as we talked about in our last answer, we cannot simplify 5 divided by 4 at all. So now we are just going to rewrite our fractions with our new simplified version. So now we have 5 divided by 4 multiplied by 5 divided by 1. Now remember that anything over 1 is actually itself. So another way to write this fraction here, or this multiplication problem, you could just write 5 divided by 4 multiplied by 5. However, just to get used to that multiplying your numerators by each other, your denominators by each other, I'm going to use the top version. However, this bottom version is acceptable as well, and your whole number just is considered the numerator, and you would just keep the denominator from your second fraction. So let's go ahead and multiply straight across. So here we have 5 times by 5, which is 25. And then we have 4 times by 1, which is 4. So you get 25 divided by 4. And then think and see if you can simplify that at all. And the answer is no. So this is your simplest answer. Okay. So moving on to example number 3. Now that I've done an example of each, my recommendation is to give number 3 a try on your own. Click pause on the video, do it on a piece of scratch paper, and then press play when you're done to check your answer and see if you got it correct. If you think you need to see another example, great. Follow through with me here and then try number 4 on your own. Okay, so here in example number 4, we have 12 divided by 3 multiplied by 2 divided by 5. So I'm just going to check here to see if I can cross cancel. We have 12 and 5, which cannot be simplified any further. And then we have 2 and 3, which also cannot be simplified any further. So that is not going to help me. So I'm going to multiply straight across. So we have 12 multiplied by 2, which is 24. And then we have 3 multiplied by 5, which is 15. And now we have to see if we can simplify any further. So we have to see if there's a number that goes into both 24 and 15. So a number that goes into both 24 and 15 is 3. So we need to simplify by dividing both numerator and denominator by 3. And we get 24 divided by 3 is 8. And 15 divided by 3 is 5. So our final answer is 8 divided by 5. Okay. All right, moving on to example number 4. Again, I completely recommend that you pause the video here and give this one a shot on your own. So here, again, we're going to test cross-canceling first, and then if we can't do it, we'll move forward. So here we have 10 and 6 as my opposite numerator and denominator. So we have to think of a number that goes into both 10 and 6. Well, 2 goes into 10 5 times, and 2 goes into 6 3 times. Okay, now let's check. We have 4 and 3, and 4 and 3 cannot be simplified. So now we are going to write our fraction. We have 5 divided by 3 multiplied by 4 divided by 3. Okay, and now we have to multiply straight across. So 5 multiplied by 4 is 20. And 3 multiplied by 3 is 9. And you cannot simplify 20 divided by 9 any further. So this is going to be our final answer. Okay. All right, let's move on to dividing fractions. So there's a mnemonic device, KFC. Yes, like Colonel Sanders, okay, from Kentucky Fried Chicken, okay. You can also use the mnemonic in the opposite order, KCF, okay, as long as it represents the same keep, flip, and change, or in this case, it would be keep, change, flip, okay. Either, order works. Just as long as you know what you're keeping and what you're changing. So our K for keep is to keep our first fraction, or if it's written as a fraction divided by a fraction stacked, then you are going to refer to that as your top fraction. Then you are going to flip your second fraction to its reciprocal. So what a reciprocal is let's say we have a fraction 3/4, then the reciprocal of 3/4 would be 4/3. So it's the flipped version, which is why we use that term flip. So we're going to flip that second fraction or our bottom fraction. And then lastly, we're going to change our division sign to a multiplication sign. Okay, so let's do an example of a division problem, and then we'll talk about why that method is allowed, why we're allowed to keep, flip, change. Okay, so in our first example here, we have 1 divided by 4 divided by 5 divided by 2. So a lot of division going on in this problem. Okay, so we're going to apply our keep Okay, our keep is to keep the first fraction. So we are going to keep our 1/4. Okay, so we're going to keep 1/4. Then we are going to flip our 5 divided by 2. So 5 divided by 2 as a reciprocal is 2 divided by 5. That's a very ugly 5. I'm going to fix that. Okay, and then lastly, we need to change our division to multiplication. Okay, and now you just apply your rules for multiplication. So you could see if there's any cross canceling that can be done, or you can see if you can simplify. So because I've done quite a few of the cross canceling, I'm gonna do this one straight across and then simplify from there. So here we have 1 times by 2, which is 2. And then we have 4 times by 5, which is 20. So now we have 2 divided by 20, so we're going to simplify further. So 2 goes into both of them. So this becomes 1/10 as our final answer. Okay. All right. Now let's discuss why we can use this keep, flip, change. Why does it work? What's important about it? So we have this problem, 1 divided by 2 divided by 1 divided by 3. So rather than looking at these as side-by-side fractions, I'm actually going to show them to you as a superfraction, we'll call it. So we have 1 divided by 2 divided by 1 divided by 3. Okay, so again, we have this big superfraction. It's 1 divided by 2 divided by 1 divided by 3. These are the same meaning right now. Okay, it's just a different way to represent them, and you will start to see this superfraction more and more throughout your mathematical career as you begin to solve more problems. So we want to look at how to get rid of our denominator. So to get rid of our denominator, we actually want to multiply by its reciprocal. So 1/3, the reciprocal is 3/1. Okay, and what you do to the top, you have to do to the bottom, or what you do to the bottom, you have to do to the top. So I'm just going to put a little divisor here. We also need to multiply 1/2 by 3/1. Okay, so let's go forward and let's actually do this multiplication. So here we have 1 times by 3 in my numerator. Okay, just so that you can follow along where I'm going. 1 times by 3, which is 3. Okay, then we have 2 times by 1, which is 2. Okay, now we have our big superfraction bar. Now we have to do it to the bottom. So 1 times by 3 is 3. And 3 times by 1 is 3. Now, let's see if we can simplify. If we have 3 divided by 3 here in the denominator, ooh, that's a little dark, I'm sorry. Here we go. Okay, so looking at this denominator here, 3 divided by 3. Anything divided by itself is 1. So now we have 3/2 all divided by 1. Well, and again, anything divided by 1 is itself, so 3 divided by 2, all divided by 1, leaves me with 3 divided by 2. So here, we multiplied by the reciprocal in order to get rid of our denominator. But we have to do to the bottom what we do to the top, and what we do to the top, we do to the bottom. So this 1 divided by 2 multiplied by 3 divided by 1, that allowed us to cancel out this denominator, and in turn, this is my keep, flip, change problem. If I were to keep my first, change my second, and change my sign, or I'm sorry, flip my second and change my sign to multiplication. These are the same problem. Okay, so that's why we can actually use this keep, flip, change method. So just keep that in mind. I wanted you to know how it works. So let's do another example together with this superfraction. So I'm just giving you this superfraction right off the bat. So we can rewrite this. We want to keep our first fraction. So we have 5 over 9. Okay. And then we are going to flip our second fraction. So 1/2, the reciprocal is 2 over 1. And then we change our division sign, which this is our big old division sign here. It changes to multiplication. We could see if there's anything to cross cancel. 5 and 1 cannot simplify. And then there's 2 and 9, which again, can't simplify. So we're going to multiply straight across. 5 times by 2 is 10. 9 times by 1 is 9. So 10/9 is our answer here. Okay, we've now done 3 different examples together. So this is where I would recommend taking a pause, trying example 7 on your own, and then checking back to see if you got the same answer as we did. Okay, so we are going to keep 3/18. We are going to flip our second fraction, which becomes 12/10, and then we multiply. And then we could see if we can cross cancel at all. So 3 and 10, nothing can cross cancel there. However, 12 and 18, 6 goes into both of those numbers. So 6 goes into 12 2 times, and 6 goes into 18 3 times. So we now have 3 divided by 3 times 2 divided by 10. Now you could choose to multiply straight across here, or you could recognize that 3 times by 3 is actually 1. So this becomes 1 times by 2/10, which is just 2/10. And then you can see if you can simplify, which in this case you can. 2 goes into itself 1 time and into 10 5 times. So our final answer is 1/5. Okay, and there's several different ways you could have gone about solving this problem and simplifying it, but at the end you should have got 1/5. Okay, just know that there's not one exact way to go about it. You know, you could have multiplied straight across from this step. You could have simplified 2/10 further right off the bat. You could have realized that could have simplified even further. So there's a lot of different ways to go about this, but at the end, your answer should still be the same. Okay. All right. Example number 6. Again, I recommend pausing the video and giving it a shot on your own. So here I have 6/7 times 10 over 1. Okay, I cannot simplify, so we get 60 over 7. All right, so here's some essential questions. I just want you to take a pause, see if you can real quick jot down some ideas. So how can understanding fractions make your life easier? And how can modeling help us to better understand the multiplication and division of fractions? Okay, so again, take a quick pause, jot down some ideas. All right, so how can fractions help make your life easier? So the first thing, which is very common, is in cooking or baking. If you need to cut a recipe in half maybe it serves 4 people, but you're only cooking for 2. You would have to cut every single measurement down by half. Okay. Or maybe it's for 4 people and maybe it's Thanksgiving and you're having a lot of family over. So you might need to triple your serving size. So you're going to need to multiply those fractions by 3. So you actually have to understand how to multiply or divide your ingredients in order to get your recipe correct. Home renovations, which kind of also goes hand in hand with some trade jobs. If you decide to replace your flooring, you have to know what angles to cut your, let's say it's wood flooring or your carpet. You have to know this, how to do the square footage, measure your furniture properly to fit in your home. If you need to replace your windows, you need to know how to accurately measure them. And let me tell you, none of them are, very easy numbers. They are all fractions. They are all, 7/8 of inches, etc. Trade jobs are very similar. Anything with HVAC, you have somebody who has to draw up the blueprints for your HVAC systems. So those are very, intense to look at and to blueprint out. And again, a lot of dealing with fractions because almost nobody's home is, perfect sizes. Carpentry, again, you have to know how to cut the carpet and measure the carpet out. You have your landscaping, remodeling, homes and gardening. And I actually just learned myself that if you are using lumber has its own math that goes hand in hand with it, which is pretty cool. And then another thing is engineers. So whether it be for the military or a private company, engineers are always working with equations. And let me tell you, nothing in life is perfect. So very frequently they are working with fractions and decimals, which are the same thing. Okay, just keep that in mind, that fractions and decimals represent each other. So that is one way to realize how fractions are really important in your own life. So next we have this video with multiplying fractions. It's how to model with them. So I already have this pulled up here, so I'm going to play this for you. So that's a problem. I want you to actually take the time to go ahead and give that a try on your own. And if you get it, I would actually love for you to bring it in for me, and I'll give you some extra credit if you complete it. That goes hand in hand with modeling the division of fractions. So now we are going to go to the same site here, and they have a video. All right, so that's how we model multiplying and dividing fractions. So again, if you complete that multiplication and division modeling problem that were at the end of each of those videos, then I will give you credit for those. But that is the end of our video.